So we saw last time. Tell you, OneNote just doesn't like zooming, it goes crazy. How's that? Is that better? Okay, so last time we saw when we're working with DDL, and I didn't really emphasize that term, but we've seen so far as we've gone through our class, we started out saying all of this is SQL, structured query language. And then we saw DML is data manipulation language, where we're inserting, updating, or deleting rows. And now DDL is data definition language, where we're defining tables and indexes and relationships and things like that in our database. So those are our different languages that we speak, and what we will see as we get into the world of work, the SQL select statement syntax is what a lot of software developers use. And then developers that are in charge of updating the databases, like creating the data access layer classes and things like that, will use the update terms. And the DBAs will use the data definition language to create components within the database, is what we usually see. So that's kind of why it's split into the different languages. So you guys saw last time that it was pretty easy to manage. We just have to remember that we always have to specify our entity type. So table or whatever that entity is that we're working with. Because when we've got something in our mind, like we want to drop the invoices table, it's really easy to leave out that term table and not be able to figure out why the thing won't cooperate with you. And it wants to be very sure that you want a specific item. So we saw a lot of the different constraints. We actually enforced a lot of these last time. So as we created tables, we saw that we could add column level constraints when we defined our columns to say whether they could be null or not, if they were a primary key. If they're a primary key, that automatically enforces that rule that they have to be unique across the table, all instances of the table. We could use a unique specifier without a primary key, but then an index would be built. We'll look at an index here in a second. We also saw that we could make those check constraints, like the value had to be greater than 0. That's a check constraint, like check the value. And then we stopped right before we created our references for our foreign keys. So we're going to create those today and see how we create those kinds of constraints. And then creating tables, we saw, again, we could create a lot of those same constraints at the table level. There's really no difference other than at the table level, we can make these things be related to multiple columns. So we can make our primary key be 2 columns instead of just 1, if we enforce that at the table level. So we just have that higher level of granularity where we can get to all of our columns. So indexes, we didn't really talk a lot about them. I kind of just glossed over them. And there's some really good stuff on Microsoft's website. I'm going to show you this picture if you're ready. I'm going to wait a second. We just had some people come in. A sec. Got a grindy noise. It feels like it should be Christmas already. Okay, I think everybody's in pretty good shape. Let's look at indexes. So I found this information on this Microsoft website. So I know you don't have a link to that. I could paste it somewhere real easy. I'll paste it in our chat. Maybe. There it is. Okay, it's in our Zoom chat. So that website talks about a lot of different things about indexes, some of the details, but this picture kind of sums it up in a nutshell for us. Here we have a table, and in our table, we have our customer ID, that's our primary key, and we have some customer data, like their names and the towns that they're in, all sorts of different columns on our customer table. And we're doing queries on this table for some of those different columns, and we have a lot of different customers. So we're seeing our performance lag when the database has to do a full table scan, and a full table scan means it has to look at every row to decide what output to give you based on your where clause. So what we can do is build an index. Now, whenever we create a primary key, an index is going to be built automatically. So if we look at our customer ID here, we have this table built in another area that just has that primary key, and then it has some sort of pointer or secondary key to get directly to that row. So it doesn't have all the information for our table, just a small amount. And in memory or in disk, wherever this data is stored, it's in sequence by whatever key we've set. Now in this example, this index is showing on city. So if we're looking for all of the customers in Chicago, our query will use this index automatically behind the scenes. We don't really have to do anything to make that happen. When it develops its plan for how to query the database, it'll say, oh, your where clause is city. You have an index built on city, so I'm going to use that index. So it'll locate all of the entries that have to do with Chicago, and it'll have a key value to go directly to that row to pull it. So that way, instead of scanning every table row to find all of the cities that are Chicago, we just have to use this index to find them. And so we can really cut down on the amount of time that it takes to access our data. Now this one over here is another index, and it's built on last name. So now if we're querying based on our customer's last name, again, the database behind the scenes can use this index and say, oh, if you want all of the customers whose last names start with C, I'm going to go to the C's in our index and start grabbing all of those rows based on their IDs and give you your results and then be done. Mm-hmm.
So these indexes essentially just let us search a little more efficiently because it doesn't have to read the whole row. It just has to read the part we're searching for.
It's not only just that it doesn't have to read the whole row, it's that it doesn't have to read the whole freaking table. Because if I want to find all of the customers whose last names start with C, I got to read every row in that table to check every one. But if I have an index, now I'm limited that I can just go exactly find these ones that start with C. So it's not so much the whole row, it's reducing the amount of table rows that have to be touched to respond to your query. So instead of having to scan through the whole table, I can just go find these 2 rows that actually start with C, give them to you, and the query's done. So we went from potentially 1 million table row accesses down to our 2 that started with C. Now, there's costs associated with that. What happens if we insert a new customer row? Now we have to get that customer row saved on disk somewhere, but we also have to update this index to put that new one in there, rearrange that array, basically that index array, and then we have to update this index to put that new customer row into it. So indexes add overhead when we're inserting or updating or deleting data because we have to get that index updated. But they speed our access tremendously. So they're usually worth that overhead. We wouldn't want to just randomly create indexes everywhere. We want to create them where they're needed, where we're going to be doing a lot of queries, but they're going to help us. Questions about it?
Well, I can definitely see where that would make things a lot easier to find.
Mm-hmm.
Because with whenever it comes, for example, I mean, I know this in a way, it's kind of like how, with how I think sometimes, it's kind of like, with me, I'm always trying to pull as much information inside my head as I can.
Uh-huh.
But technically, that's another way of limiting.
Yeah, it's just another access method, another way to get to your data. Uh-huh.
It's occurring to me that it must be very important to make sure your index is sorted properly.
Well, and that's something that's going to happen in the database management system. So when we create an index, let's look at that because I jumped past it the other day.
But that is in fact the thing that happens and needs to happen.
Yes.
It's just happening behind the scenes. And we don't
Behind the
have to
scenes.
worry about it. Okay.
So let's look at, this was page 11 of that presentation. And I just sort of skimmed on past it till we were ready to talk about it. So here we can create an index. This create statement allows us to say whether our data should be clustered in the same order as our index or not. Now, whenever you have a table, how many clustered indexes do you want? What if you try to cluster on another field?
It won't know how to sort it.
Yeah, it can't. It can only store it close to one index in one order, basically. That's usually our primary key. It's usually going to be our clustered index. And the database, at least SQL Server that we're using, is going to automatically create that clustered index on our primary key for us. So we need to create indexes on foreign keys because we use those for queries a lot, right? So anytime we have a foreign key, we should probably create an index, a non-clustered index, using that foreign key. So our syntax is create index, then our index name. In our textbook, they name their indexes with the IX underscore prefix, which is a widely accepted practice that we'd like to follow because that then keys to us that that's an index entry. After we name our index, we use the on keyword to specify our table and then our column list that this index is going to be created on. So this create is going to create an index, whoops, got it to do something, just on vendor ID. And this one is going to create one descending on invoice date and then on invoice total. And we've seen as we've queried that we do use that invoice date a lot in this system for different things. I wonder what I did. It looks good. I need to come in here someday. Look, now I got some other weird icon.
On this second one where it's got two different columns in the parameters,
Uh-huh.
essentially saying sort by date first and then resolve type by sorting by the total.
Yep.
Okay. How many could we do that way? Could we sort every column that way? There's just here's the order of sorting for each and every column.
We could, if we did, it would be a huge resource drain to update our table because we would be updating so many different indexes. And another thing that we want to be concerned about is we don't really want to have a lot of duplicates in duplicate values in these columns because otherwise it makes it hard for the index to decide what order things should be in. So we want to be kind of judicious with its use. It's important and it's really usable. Let's create an index on our little invoices one table that we created. We won't see any difference in performance. That's one problem with us using the small database tables is that we just don't have enough quantity for us to see what an impact this could have on a large table. It's mad at me for closing ugly. Okay, I'm gonna find the right one. C# people, don't forget to find the right one.
You make sure, like, oh yeah, just save the page.
Do what?
I was like, how do you tell? And I was like, oh wait, yeah, that's like,
Do you see it?
yeah. Yeah, I was like, oh wait, yeah.
My ring is telling me cars were rummaged through last night in our neighborhood.
Uh-oh.
I know. You know, I like the ring, but boy,
Do you have the
sometimes.
Still don't?
Uh-huh.
Yeah, there's a huge rate of this being stolen.
I believe it. There's not much keeping it attached to the house. You know, if you've got the nerve to walk up and grab it.
Yeah.
Or a mask. Like I could mask.
Put your come your face, yeah.
It wouldn't be able to recognize me.
We'll just see it, put it aside.
My phone can't recognize me. Okay, I'm going to go into my database and let's see what we had created here in our tables. Oh yeah, we have lots of invoices tables that we can experiment with here. So let's create this vendor ID index on our invoices 1 table. So I'm going to open a new query window and use my database. And I want to do the create, and my entity type is index. And then I'm going to give it its index name IX underscore vendor ID. And we're creating it on our invoices 1 table on our vendor ID column. Now we can go ahead and put in our syntax to create our other index also. We're going to create an index called IX underscore invoices. And this one will be on our invoices 1 table again. We want to use our invoice date as a descending index and our invoice total. Should be good to go. Now, if I look at my invoices 1 right now, you don't have to look at yours. Yours should look the same. Notice that we actually have a property under our table for indexes. And if I expand that right now, I do have one because I have that primary key index that was created automatically for me. Do what?
We don't have invoice date on that table.
What do we have on it? No, we don't. So we'll have to use our regular invoice says table. Will that work? Now I'm going to check our regular invoices table and see what it has. And right now it does have a vendor ID sort of thing, but ours isn't going to hurt anything because it has a different name. So we're gonna kind of over index it, but we'll go ahead and run this query. And now if I update or refresh over here in my Object Explorer, I should be able to see those new indexes. Now we can also create what's referred to as a filtered index. And this is something that you may have in a given database management system, or you may not. SQL Server supports it. And what a filtered index is an index that allows us to specify kind of a where clause. So this index is only populated with rows that have a payment date of a null value. So this would be kind of like all of our outstanding orders would be saved in this index, our outstanding invoices. And then this filtered index would be created only for invoices that are newer than February of 2016. And we might want to do that, again, if we have a really, really huge table and we have some sort of query that's really dynamic that just wants the last few weeks worth of data, and then we could constantly be changing that index. Sometimes we have things like that that have to be updated in the actual structure of the database to accommodate our data, but we try to get away from them. Okay, so that's a filtered index where it's just a subset. So that's pretty much it for indexes. We don't have any other syntax available for those. So understanding that it's kind of an array built to access our data quickly will help us think of where we should create, and we should always create an index on a column that's a foreign key, and then we should create an index on a column that is often queried and seldom updated. That's our best bet. Okay, so let's go back. We were a little further than that. I think like page 25. Around in there. Make sure we don't skip anything. Our foreign keys. Okay, so the last thing we did last time, if you remember, was this vendor number matching, where we said that our vendor number had to meet a specific check constraint requirement in order to be saved. And we came up with this thing where the first two characters had to be alpha and the rest of it had to be numeric, and the first two characters had to match the vendor name. So that was the last thing we did the other day. So on page 22 then, we start with defining our foreign key references so that we can create those referential constraints. A referential constraint is the kind of constraint that says you cannot insert a row in this table unless a row already exists for the tables I'm dependent upon. That makes sense. And so our referential integrity ensures that we don't have orphaned rows out in our tables that don't have, matching vendors or matching customers or whatever the case may be. So our syntax depends now on whether we're going to add this constraint as a column level or a table level. But no matter what, we're going to say that this references another table. So that's the important syntax of that references keyword and then the table that we reference. After the table we reference, we specify the specific column in that table. Let's look at a couple. Makes more sense when we're not looking at the actual syntax because there's so many options. So here's one. We're going to create this table, vendors 9, with just a couple of columns in it. And then we're going to create another table, invoices 9, that is dependent upon that vendor table. So in our invoices, we're going to include this clause, references. We're going to say this vendor ID on my invoices table references the vendors table, vendor ID. And that creates that constraint that says you can't insert a row in this table unless there's a matching row in the vendors table. So let's create those. I'm going to do a new query window. And I want to create table vendors 9. And we just had a couple rows. Vendor ID is an integer. It's not null. And it's our primary key. We already have a vendors 9.
Yeah,
What does it have?
I do not have a vendors 9.
We have invoices 9. Let's
Yeah,
see.
invoices 9 here. Right? Missed something on Tuesday? I'm pretty sure I was here.
I have both vendors in it.
Yeah.
Did we already add that constraint? I don't see it.
Your vendors 9 for the very bottom.
Well, let's drop them then first. So we'll drop table vendors 9 and go so that it goes and drops that table before it continues processing our batch here. And then we'll recreate it. So we won't have to worry about it. Do what? We'll drop it to now in our vendor sign, we want our vendor ID and our vendor name both not null. Do what? Okay. We'll drop it just for the fun of it. Because I'm missing parts of it. And so we'll just make sure everybody's got the same thing. Now, after we create our, sorry, talking and thinking doesn't work. I want to go ahead and drop our invoices 9 table in case we have one, and then create it again. So a batch file, database creation batch file will often look like this, where we'll drop the entity and then create it again to recreate it, because it is so difficult to alter our tables. And when you start creating your tables today, hopefully you'll run into a little bit of trouble. So you do want to alter your tables so you can see what kind of things you can run into. All right, so on our invoices 9, we're going to have invoice ID. It's an integer, not null, and it's our primary key again. And then our vendor ID is an integer, not null. And here is our clause that says that we have a relationship. This column references the vendor's 9 table, vendor ID column. And then our invoice total is money, and we will allow nulls. Bless you.
Thank you.
Okay, let's see what kind of errors we can get. Let's try it. Could not drop vendor's 9 because it is referenced by a foreign key constraint. So what should I do? Huh? I heard it. We gotta drop our invoices 9 first, because it's dependent. So I'm gonna drop, I have to drop it at the very beginning. So let's try that. So it's much happier with that. So notice our order is significant, because once we've had these relationships created, these references in our database, we can't just carry, get rid of things. Okay, now I want to refresh over here on my tables and see if I can see both of my tables. It says all of my commands completed successfully. So I should be able to find my invoices 9 table and my vendors 9 table. In my invoices 9 table, I should be able to expand it. And I should see my primary key and my new foreign key. Let's look at the properties on our foreign key. Oh, it won't let us, will it? Let's see what happens if we choose modify. Now, this is the foreign key relationships window that we would see if we were setting up this relationship using the GUI. So this is what we're presented with here. If we try to change it, notice what we have when we look at our relationship here. We have its name that was automatically defined. And then down here where we have the insert and update specification, we need to expand that And we could change those cascade rules so that if a vendor were deleted, we could specify that we wanted to cascade that delete to delete all associated invoices, same with updates. Look at your tables and column specifications also, and notice that's where we've got specified what the base table is and what the dependent table is. Mm-hmm. Drop table vendors, 9. You have to drop the invoices 9 first.
Also, you probably shouldn't drop the actual vendors table.
Yeah, make sure it's vendors 9. Thanks,
Probably
Seth.
not a great idea.
That'd be owie. Okay, so we can create these relationships through the graphical user interface too. All right.
Not fair. It might be upset that you're trying to do it at some point.
It just depends. It just depends on people. I don't know. People say it is. To me, I would look down on somebody who wastes their time by worrying about doing everything through the command versus doing it through the GUI, because you should use whatever's going to be the most time effective for you at this point in time. And to me, I would say if you're sitting in your office and you can quickly use all of your create and drop syntax, your DDL syntax is much faster. But if you're working with a group and you want some sort of visual aspect so that everybody's working together, then I think the GUI would be a better tool to use, because you're bringing the whole group together kind of with something to look at. But either way, remember, you can generate that script file after it's done. So if you're lazy bones and you want to use the GUI, you just go in and you say script table as my create to a new query editor window, and it'll output our DDL to create that table. So we can always be a lazy bones and make it look like we weren't. That's it. When I was a DBA, there was only the commands, so. I would fault nobody for using a GUI. I would be like, yes, you use it if you got an option. But I don't like doing those look down upon things. All right, so whenever we create that relationship now, let's insert something and see if we can make it angry.
This SQL query tree that you had a moment ago. Where did you pull that from? Were you typing that while I was trying to help Pong here?
No, I just did that right click on the invoice table, script table as, create to new query editor window. So remember, no matter what you do, you can script it and generate that DDL code that you can save off somewhere.
Okay, that's all that is.
Yeah.
All right, carry on then.
So I would save that code definitely after the database was created. You want everything saved, all of your source code. Save it to GitHub, save it someplace safe so that you've got a copy of it. You know, it might change a lot at first and then it will go for a really long time without changing ever again. So we created our indexes and our relationships. Let's try to insert into our invoices table. And it shouldn't matter what we try to insert. We don't have any vendors in our vendors 9 table, right? So our insert should fail. Now our insert would not fail if we hadn't created that referential constraint. So when we run this, we should get something that tells us. Everybody get it? So you set up a constraint. So let's put those in our notes and Let me find that page. So I'm just gonna do, I don't know, referential constraints. So a referential constraint, we make this one bigger. That's pretty much what we call a foreign key. This is where a table references another table. Now we use these referential constraints to enforce referential integrity. And we can cascade deletes or cascade updates. Now, if that doesn't make you think of something, if you don't understand what that is, add more to the notes and say, you know, it will delete all of the sub records or update all of the sub records or dependent records or rows. So that constraint again can be added at the column level or the table level. We saw that. So good, we know pretty much now how to create everything in our database. We haven't created everything, but a lot of stuff.
Can you go back to the invoices line? Create. I'm sorry.
Uh-huh,
I just wanted to take a look at it.
this one right here.
The other one. Or wait, I think it was the fourth one.
This one,
Yeah, that one.
okay. Do you see it?
Yep.
You got it.
Now I got it.
Okay, now the rest of the stuff that we're looking at is pretty straightforward. When we drop something, the syntax is super simple. Drop, entity type, entity name. When we are dropping an index, we also have to specify the on keyword with our table name so that we can make sure we're specifying the index and table. So we could have the same index name on multiple tables. So we do have to specify that table name. We cannot delete an index that's a primary key or a unique key. That's controlled by the system itself. You might have to delete or drop indexes before you can drop a table. We saw we had to drop our dependent table before we could drop kind of the owning table. So it's not the syntax that's difficult, it's the ordering, making sure that we get everything dropped and recreated in the correct order. So we can generate a script to create all our stuff, but we have to make sure we drop everything in the right order to be able to recreate everything. When we drop a table, again, it's pretty simple. Drop table and the table name. Remember the qualification parameters where we could specify our server name, different parameters. Can't delete a table if a foreign key constraint in another table refers to it. So that's what kept us from dropping our vendors table. We could drop the whole database. Don't do that.
Probably not a good idea.
Now the alter table, if you look at it, you can see pretty easily why it's seldom used. Usually people just drop the table and recreate it. If you try to alter a table, often you won't be able to anyways, because if there's already data in the table, the database management system is going to keep you from changing many things about it. It's going to say this could affect the data. I'm not going to let you change it. So that's why over the years, they've just developed the habit of dropping and recreating. So the alter syntax does exist. We can alter the table. We can add a new column. We can drop columns. We could alter an existing column. So notice inside the alter table syntax, we have add, drop, and alter for our columns.
It sounds suspiciously like it's not that great of an idea, though.
It's not. So you can do it. And you mostly would do an alter table if you wanted to add a constraint, because that's something that you could do probably without having too much of an impact. And again, then you'd want to generate that DDL definition script file again and save it to GitHub or wherever you've got your source code saved for creating your database and all your tables. Just going to keep that saved somewhere. And here they've got some examples of altering a table to do some of those different things. Adding a column, dropping a column, adding a check constraint, adding a foreign key. So we would do that. Now we can create a sequence. This is kind of neat. If we can do it right, I'll create it and then you guys should be able to use it. Let me see if I can get one. I'll get it created here. So this sequence is like a counter that's running on our database management system. And once I create it, everybody should be able to access it. Let me run this. Okay, so it is created. It's called task sequence 1. So what is it that I need to do? You should be able to. Let's see what we can do here. We can select current value from sys sequences. Where name equals one parenthesis test sequence 1. And now let's see if we can run that. I might have to add something to it. Okay, it's 1. So can somebody update it? Let's create a table that uses it, I guess.
I didn't get anything back.
You didn't get anything back? It won't let you see it?
I just got,
I mean, like, it returns the thing. It shows a column called current value, but it doesn't show anything.
Mine shows what yours.
It does show the one? Let me create this table.
Yeah, so she's wanting us to use the one she created, that's why you see it. You're using X to yours. We're trying to
Yeah.
That's supposed to be.
So,
Let me create this table.
should we also keep trying to create this table? Or
No.
no? Maybe not.
You might be able to create, yeah, go ahead and create it. And then we're going to insert into our table, into sequence table. Values. And then for our value, we want next value for test sequence 1. Oh, and then we want another column. I'm going to make it say inserted row. I wanted to say first inserted row. I'll do it like that. Okay, so first inserted row, and then we're going to copy this. And say second inserted row. And then I'm going to try to select everything from our sequence table. Bless you. Okay, so I think that I need to run these statements. And I'm going to use, I wonder if I need to use master. Let me do it. Uh-huh. Hang on. Just a sec. Got too much junk here. Let me slide this down. Okay, so I'm going to create this sequence, test sequence 1, in the master database so that we should all be able to see it. Maybe we shall see what happens. And then each of us are going to create our table that is dependent, or our own table. Then we're going to insert into our table a number that we gather from that test sequence. And if it works properly, we should all get different values because this sequence thing should be keeping everybody's values separate. So let me create it. Uh-huh.
So should we run the select part value?
You don't need to. But I'm going to create this first part. And so then let's all run all of this from the create table statement. I'll add my use also. Now I got 1 and 2. Did everybody get 1 and 2?
It says that test sequence 1 is an invalid object name on mine.
It's mad at you. Put, let's see if we can see it. I can't remember what we had to do. Try. Master. That test sequence 1. Does that let you see it?
Were we supposed to create it ourselves?
Hmm?
Were we supposed to create it ourselves?
You shouldn't have to. We should all be able to access this same test sequence 1. That's our point, is we want to all share this counter so that nobody gets a duplicate value for this number. But I don't think that it's quite there. And it's not liking that master.dbo maybe. We'll fully qualify this a little bit more since it's not in our tables. It still doesn't like it. Well, I will fiddle with it and interrupt you guys while you're working and see if we can get it to work. So got it to work. The last couple of times we had class, and it's pretty neat because you can see how it's keeping a unique value for the whole server for everybody to play with. So if we can't get it working this time, I'll get it figured out for next time. Do I? Did it let you? It's letting you do it for you.
I don't know. I create a table by mistake, and I can't insert the table. I don't know exactly the table. It's my table. Mine's a math. Let's see here.
You just write line 17.
Here.
Sure. Yeah, it's not working the way it needs to. So I'll figure it out because I don't want to take you guys' time to get it working. Now, after we've got this sequence set up, we should be able to just share it across the server so that like we always have a unique next number for whatever we need. The database itself takes care of our identity columns, so we don't need to assign like a next invoice number or anything like that. But sometimes we do have like just a transaction number that we want to keep separate for different locations or something like that, so we can use a sequence. So it's a pretty neat thing. You guys have been using the Go command. You know how to use a specific database. That's one of the other DDL syntaxes. And our SQL scripts are basically all of this code that has been generated. And like I said, we want to make sure to save all that so that we can recreate all of our tables if we need to. Let's look at chapter 12's PowerPoint. Go back to our modules. It is super short. And it is about how to use the graphical user interface.
There's a GUI within databases.
That's what we've been using. So if we want to create tables using our GUI, we saw it from the very beginning how we could do it. And you should feel pretty comfortable with it. And, you know, with the GUI, you want to just be able to move quickly and find what you want. And if we want to see what columns are in a table, we can right-click on the table and do properties. Now, when you're looking at the properties, you have different things that you can take a look at. The general information is not the columns, I sort of lied, but you can see information about where the table is stored, if it has special information for what file it should be kept in. We can have permissions on our tables, like what people can select from it, what people can insert into it, so we can have a really high level of security. Our extended properties, we could just go crazy with all sorts of things. Now, if we right-click on our table and choose design, we'll see all of the columns and in the design mode on the graphical user interface. So again, we have our column name, data type, and whether or not we allow nulls. Down at the bottom are the specific properties for this individual column, and our identity specification is down here. We have to expand that and say yes to make it an identity column. Now, one thing that is important to use the GUI for is getting a view of our database diagrams. And you know we had trouble with that from the very beginning of the semester. So let's see if it's like, I think that we might be able to get it working. Double click on database diagrams. You're able to get it to work for our C# class. When you double click on database diagrams, it should pop up with some sort of dialog box asking if it can install things, and say yes. I have already done that, so mine didn't ask me.
Oh, wait, if it doesn't ask you, we'll have it.
You should be okay, yeah. Well, we'll see. Now, the part that was crashing us before, let's right-click on database diagrams and create a new database diagram. So far, so good. How's you guys doing? It's giving me all of our table names, and I want to pick, let's pick our invoices 9 and vendors 9 tables. I'm going to hold control to pick that second one.
We're creating a new database diagram.
Now with just our vendors 9 and invoices 9, let's add those 2 tables to our diagram. And then we can close this add table dialog box. And so it puts them on our diagram for us. We can move them around if we want to. Now, when we're looking at the database diagram, we can't really change the tables themselves, but we can work with the relationship. So if you click right on the bar that is our relationship, you'll see that the IntelliSense shows you the name of the relationship and kind of a little bit about it between vendors 9 and invoices 9. Now you can right click and you could delete that relationship, or you can go to the properties. The properties looks a lot like that relationship window that we were looking at earlier. It shows you your tables and columns. Now, when I click on that in my properties window to see the tables and columns that are in this relationship, notice they're grayed out. So if I do the ellipsis, that brings up the dialog box that will actually let me change what tables I'm working with here. Let's delete that relationship. And let's create a new one. So to create a new one, I'm going to click on my vendor ID in my dependent table. We'll see if that's right. And I'm going to click and hold on that vendor ID column and drag up to the vendor ID in my vendor table. Now, if you notice, the management system picked the right table as the primary key, and the right table is the foreign key, and said what our columns are. Now, when I click OK, I still need to check my cascade settings to see if I need to delete cascade deletes or cascade updates. And again, I could go back to this foreign key relationships window at any time. Now, when I click OK, it's going to show that relationship in this diagram, but it's not really saved. It's kind of weird. So I'm going to click to save this diagram, and I'm going to save it as my vendor 9 diagram. And when I save that diagram is when it's actually going to issue the alter table statements for me to create that relationship. It says these tables are going to be saved. Do you want to continue? Well, they're going to be saved because they're going to be changed by adding that relationship. So we can say yes, and it'll update those tables. It wouldn't let you. Did you double click on database diagrams and say yes to install that stuff? You have to double click on it first. I think that's what we were missing. Yeah, the database diagrams itself. Double click on that. It doesn't do anything. And when you right click and do new one, does it crash? Like it did before? I don't know how it's. Everybody else's work okay?